Good evening to all of you. This is lecture 35 in the fourth unit, properties of a pure substance. So today I am going to cover the numerical problems on pure substance, how these problems are carrying out in thermal power plants. So first, initially you should have to know the evaluation of the properties of steam and water mixers in thermal power stations. So in boiler, how the properties can be evaluated. In steam turbines, how the properties can be evaluated. In condensers, how the energy conservation equation, that is the steady flow energy equation, can be applied, and based on that one, the properties can be evaluated. And in the feed pump, so how the properties can be evaluated. So all these things are connected to the pure substance, which is basically this particular topic is used in application point of view, the thermal power stations, steam thermal power station especially, because the pure substance is nothing but ice plus water plus steam, that you can call it as a pure substance, right? So now entering into the problems. So first thing is, in this particular case, let me going through the cases. So these are the problems connected to this particular side. So have the discussion onto this side. So what is the first problem? Find the saturation temperature. Find the saturation temperature, that is the saturation temperature, the changes in specific volume, entropy during the evaporation process. This is the evaporation process. So conversion of a liquid to the vapor state, it is called as the evaporation. And the latent heat of vaporization of a steam at 1 bar, and or you can consider it as a 10 bar. So 1 megapascal is nothing but equal to 1 into 10 to the power of 6 Pascal. That is 1 Pascal is equal to Newton per meter square. So that is equal to, if you make it as a pressure, that is pressure is equal to 1 megapascal. So that is equal to 1 into 10 to the power of 6 Newton per meter square. This Newton per meter square you can call it as a Pascal. So that is equal to, if you write that one, this one as 10 into 10 to the power of 5 Newton per meter square. So that is nothing but equal to 10 bar. So 1 bar is equal to 1 into 10 to the power of 5 Newton per meter square, right? And if you want to make that in kelvins, so that is pressure is equal to 10 bar is there. So 10 into 10 to the power of 5 divided by 1000. So now you can get as in kilopascal. So 3 zeros getting cancelled, and here the 3 zeros moving, and only 2 are there. So that is nothing but equal to 1000 kilopascal. So this is how you can keep the pressures in megapascal, pressures in bar, pressures in kilopascal. So this is the first basic fundamental step a student has to identify this particular side. The conversion factors are also important for solving the numerical problems. Now, when you observe the steam tables here, so from the steam tables, just quickly recap from that particular steam tables, that is at 1 megapascal. See here, the saturation temperature based. So you have to use the saturation temperature based steam tables. So at 1 megapascal, you can find the saturation temperature. So already in the 34th video lecture, I have shown how to use the steam tables. So now what you have to do is you have to keep the steam tables with you. That is a printed book or it is a printed material. You have to keep that with you. And whenever a given problem is given, so based on 1 megapascal or it may be the 10 bar or it may be the 10 bar. So corresponding to this one, that is corresponding to this one, you have to record the saturation temperature. That saturation temperature is 179.91 degree centigrade. And corresponding to that one, you have to note down the specific volume of the fluid. This is the specific volume of the vapor or gas, right? Specific volume of the vapor or gas. Then once it is over, then you can find out the VFG, that is equal to Vg minus Vf. See, this is the specific volume. See, because it is in meter cubed per kg. So in meter cubed per kg, it is the small v, right? So this is all. These things are in meter cubed per kg. So what they have asked, changes in specific volume, right? So changes in specific volume means at 1 megapascal, what is the Vf value? What is the Vg value at 1 megapascal? What is the Vf and Vg value at 1 megapascal? So that are nothing but these values are there in the steam table. So try to find out and you will get the VFG value is 0.1933 meter cubed per kg. So this is nothing but the changes in specific volume. So after then they have asked the entropy change during the evaporation. So evaporation means this is what liquid vapor mixture. So that is nothing but equal to Sg minus Sf. So the Sg value at 1 megapascal or 10 bar, Sf value also 1 megapascal at 10 bar. So if you record that particular value, Sg value is 6.5865 minus Sf value is 2.1387 kilojoule per kg. So then you can get the value as 4.4478 kilojoule per kg. So VFG is also over. Next one is the latent heat of vaporization. So that is nothing but equal to HFG is equal to Hg minus Hf. So this also at 1 megapascal. This is also at 1 megapascal. If you note down that particular values, then directly you can get it as 2015.3 kilojoule per kg. And this entropy is kilojoule per kg Kelvin. See, the units is also very important. Try to take care of about the units conversion and mentioning the units related to that particular variable. So this is the first problem. So that is the first case. Now moving on to the second case. So the second problem is it is mentioned that saturated steam has the entropy value is mentioned. So from the steam tables, you have to identify this particular value where this is located, 6.76. Corresponding to this one, what are its pressure, temperature, specific volume, and enthalpy? See, the saturated steam where the entropy is mentioned in the steam tables at some location. You have to identify that one. So corresponding to this one, that is the Sg, because it is a saturated steam, means it is a vapor. It is a vapor. So what we have told, in the vapor state condition, then you have to note down the specific volume Vg, enthalpy Hg, entropy Sg, right? Internal energy Ug. So saturated steam means it is the vapor state. Then you have to record the Vg value, Hg value, Sg value, Ug. So that means here this is given as the Sg value is already given, and related to that one you have to pick up from the steam tables. Then what is its pressure? So that pressure is 0.6 megapascal. You can check it from the steam tables. And the saturation temperature. So small t is nothing but the saturation temperature corresponding to this 6.76. So that value is 158.85 degrees centigrade, and Vg value is, so that is the Vg is equal to 0.315 meter cubed per kg, and Hg value is there, it is 2756.8 kilojoule per kg. So from the steam tables, you have to keep these things with you and try to see this particular. So sometimes they may mention the saturated liquid. So sometimes they may mention the saturated liquid. So saturated liquid at this state condition, what are the things you have to note down? That is specific volume Vf, enthalpy of the fluid, entropy of the fluid, internal energy of the fluid. So a student must be very careful about this particular thing. Saturated liquid state you have to note down. Saturated vapor means you have to note down this particular things in the saturated vapor. And during the evaporation, that is the phase change condition, during the phase change condition, then what you have to record? Evaporation or the phase change, that is HFG, SFG, VFG, and UFG in the evaporated state condition. So this is the evaporated state condition, right? So these things student has to observe in this particular state. Next, moving on to the third case. See here. Find the enthalpy, entropy of a steam when the pressure is 2 megapascal. When the pressure is 2 megapascal. So when the pressure is 2 megapascal, find the enthalpy and entropy. So from the steam tables, that is the 2 megapascal is given, that is nothing but equal to 20 bar, that is nothing but equal to 20 bar. At 20 bar or at 2 megapascal, that is you can note down that particular value. So that is Vf is 0.00 from the steam tables, 0.001177 meter cubed per kg, and Vg value is 0.09963 meter cubed per kg. So that is in this meter cubed per kg. Then what you have to find? You have to find out the initially the quality of a steam here. You have to find out. So that is nothing but equal to specific volume is equal to Vf plus X into VFG. Right? So in this particular case, the specific volume is mentioned. See, observe this one. So based on this one, when you note down this particular things, that is Vf and Vg value from the 20 bar, then you have to conclude the conclusion that this value lies in between these two. This value is lying in between the two, right? So when it lies, because this is here 0.09, but what is Vg? Vg is 0.09963. So that means this value is lying in between this particular cases. So then this V is nothing but equal to 0.09 is equal to Vf is 0.001177 plus x you have to find. So you have to find the dryness fraction of a line, right, into the Vfg, that is nothing but equal to Vg minus Vf, Vg minus Vf, right? So Vg and Vf values are given over here. Corresponding to this one, you can get the quality of steam, that is x is equal to 0.904. 0.904 you will get this particular side. 0.904 you will get. Then what you have to find? You have to find the enthalpy and entropy. Then enthalpy is equal to H is equal to Hf plus x into Hfg, right? So Hf that is at 20 bar at 2 megapascal. The value is from the steam tables, you try to get it 908.79 plus x value is 0.904 into Hfg value is 1890.7. So this total value you will get this one as 2618.79. This is kilojoule per kg. Kilojoule per kg. So in the same way, that is S is equal to Sf plus x into Sfg. So at 2 megapascal or at 20 bar, right? So if you work it out, then here that is also Sf plus x into Sfg. Sf is 2.4474 plus 0.904 into 3.8935. So you will get this value as 5.9534 units is kilojoule per kg Kelvin, right? So this is how you have to solve this particular problem. So the basic fundamentals, these things are required. So this is how you have to clear the things. Next, moving on to the another problem. Moving on to the another problem. So here what it is given? Find the enthalpy, entropy and volume of the steam. Find the enthalpy, entropy and volume of the steam at 1.4 megapascal and 380 degree centigrade. 380 degree centigrade, right? So in this case, how you are going to find out? So that means when you open the steam tables, right? So the pressure is given as 1.4 megapascal. So that is nothing but equal to 14 bar, right? But corresponding to this one, the saturation temperature. So if you observe that the saturation temperature at this case, it is from the steam tables, it is as 195.07 degree centigrade, right? So that means this value, the saturation temperature is less than the given temperature. So 380 degrees centigrade. So that means here, this is the given. given temperature. This is the given temperature. Then what you have to take? So steam lies in the superheated state. Steam lies in superheated state. Steam lies in superheated state. Right? So now open superheated steam tables.